non-traded good and the traded good. So I'm going to write these equations in a simple way. I will not write the time subscript, okay, just to simplify. So the price level in the home country is a weighted average of the price of non-tradables and tradables. Likewise, price level in the foreign country is also a weighted average of non-tradables and tradables. So that's the first set of equations. Now, in the paper, we also allow this CJT is a stationary random variable that would be something like a measurement error. Okay? But because in general, the price level may not be constructed in this way. Okay? But we are modeling it like this as a geometric average of non-traded and traded goods. But in reality, price levels are not constructed like that. Okay? So that is okay with us, as long as this deviation from this geometric average is stationary. It's not going to affect our analysis. Okay? So CJ is like a stationary measurement error. Next is the nominal exchange rate. 1 unit of the home country currency is E units of the foreign country currency. So that's the nominal exchange rate. So let's suppose that the US is the home country and the foreign country is the euro area. So the exchange rate, then nominal exchange rate, is going to be measured as the number of euros per dollar, number of units of the foreign currency per unit of the home currency. You could define this in any way you like, right? So that's how this paper defines it. Then the next equation defines the relative price between non-tradable good and the tradable good. So Q is Pn over Pt, relative price of non-tradable to tradable goods. So in the home country, QH, relative price of non-traded to traded goods in the home country, and in the foreign country, that is the relative price of non-traded to traded goods in the home and foreign countries. These relative prices will play an important role in explaining why PPP fails to hold. Okay? So we're going to show that. So that's the second equation. Third equation is the real exchange rate. So this is the relative price of home goods to foreign goods adjusted for the nominal exchange rate. Okay, so notice that H is the US, so this is in US dollars. The nominal exchange rate is in euros per dollar. So the nominal exchange rate will come here. So that when you multiply them, you get something which is in euros. And in the denominator, the foreign price level is also in euros. So the units are the same. So that's the real exchange rate, relative price of home goods to foreign goods. Next, now PPP, we should expect that it should hold for traded goods, but not for non-traded goods. And even for traded goods, it may not hold in the short run, right? Because arbitrage takes time, it is expensive, and so on. So, because traded goods across countries may not be identical, PPP may not hold, even for traded goods in the short run. So we assume that PPP holds for traded goods, but only in the long run. So what does that mean? Okay. So we assume PPP holds for traded goods in the long run. What does that mean? So our nominal exchange rate is in euros per dollar. Right? So if PPP holds for traded goods, then we would have something like this. So this is the foreign price of traded goods, and this is the home price of traded goods. This is in euros, this is in dollars. So the units match. If we take log on both sides, then we have this. Now I'm gonna just rewrite this. So if PPP holds for traded goods, then this is what we should have. The home price level of traded goods equals the foreign price level minus the nominal exchange rate. Now we are saying that PPP holds for traded goods in the long run. In the long run. So this equation may not even hold in the short run. So we add an error term to account for that. So log of the home price level of tradables, log of the foreign price level of tradables minus the nominal exchange rate plus a stationary error P. Okay? where this P is I0. So that's equation 4. So the fact that P is I0 tells us that in the short run, PPP may not hold, even for tradable goods, but in the long run, it should hold. Okay? Okay, so now let's simplify the price level of the home and foreign countries. We're going to derive this equation now. So recall the price level of the home country is a geometric average of the traded and non-traded goods prices. Alpha H is the share of non-tradables in the overall price index. 1 minus alpha H is the share of tradables. So if you take log of PH, then we get this. So this becomes a linear equation now. And I'm going to combine these two. We have alpha H log PHN minus alpha H log PHT. So then I get and PHN over PHT is nothing but so this is nothing but Q. Q is the relative price of non-traded to traded goods. So I can write the price level of the home country in this way. And by symmetry, the same thing is true for the foreign price level as well. So the price level in each country can be written in this way. Is this clear? Is it okay? So that's these equations over here. Price level in each country, log of Q and price of Q. Okay, now we are almost there. So using all the equations we have written down up to now, we can get this equation, okay, log for the real exchange rate. So let's take a look at this. So log of the real exchange rate, recall our real exchange rate is this. So this is log of the real exchange rate, so I can write it as like this. Now, from equation 5, log of pH is this, and log of pF is this. So I'm going to insert these over here. And then what do I get? So I get this. Now, I'm going to rewrite this. So I'm just rewriting this. I'm putting together the two relative price terms, QH and QF, and the other three terms, I combine them together. Now, what do we know about this term in the brackets? What do we know about this term in the brackets?
Going to your error.
Yeah, this is the error for right, so this is the error term from this equation. Right? So this error term, we said if PPP holds for traded goods in the long run, then this error term should be I0, it should be stationary. Okay? So basically what we are saying, I can replace this error term, this should be I0. If PPP holds for traded goods, as we are assuming, this error term should be stationary. Okay? So So what we have shown is that the log of the real exchange rate is going to be a weighted average of the relative price of non-traded to traded goods in the home country and the foreign country, plus an error term which should be stationary. Okay? It should be I0, provided PPP holds for traded goods in the long run. Okay? So our assumption is PPP holds for traded goods in the long run, so this part is stationary, and therefore we have this equation. Now what is this equation saying? Okay? So we are trying to explain why is it that PPP may fail to hold in the long run. And we are saying, well, the reason for that is that the real exchange rate is really a linear combination of the relative price of non-traded to traded goods at home and in the foreign country. if these relative prices are very persistent variables, if they are non-stationary or close to non-stationary, then the real exchange rate will also be non-stationary or close to non-stationary, which is what we find in the data. Okay, so what we are saying is, well, if PPP holds only for traded goods, then the real exchange rate is going to be co-integrated with these two relative prices. Okay, relative prices of non-traded to traded goods in the home and foreign countries. Okay. Now, why would these relative prices have a unit root? Okay. We are not addressing that question here. We are just saying, well, if these variables have a unit root, so should the real exchange rate. Okay? And we expect that the real exchange rate should be co-integrated with these relative prices. So that's the equation that we are interested in testing. Can we find measures of the relative prices of non-traded to traded goods such that we observe co-integration between the real exchange rate and these relative prices? Okay? So that's the main result that we are interested in testing. Okay, so I've skipped a few things to keep the derivation clean, but you can, like measurement errors, etc. But the important thing is this equation. So we derive this equation showing that the real exchange rate is a combination of these two relative prices plus a stationary error term. Now, if the relative prices are stationary, then of course the real exchange rate would also be stationary. But what we observe in the data is that real exchange rate is close to I1 or I1. So we assume that the relative prices themselves are I1, okay? And they are causing the real exchange rate to be I1. And of course we can test these assumptions with the data. So the first assumption is that log of the relative price of non-tradables is I1 in each country. The second assumption is PPP holds for traded goods in the long run. So as long as these two assumptions hold, then equation 6 implies that log of the real exchange rate is going to be co-integrated with the relative price of non-tradables in the home and foreign countries with this co-integrating vector. Okay. Is it clear? Okay, good. So now there's one more assumption, which kind of a technical assumption. I'm not going to talk too much about it, but we are assuming that the two relative prices, they are not co-integrated with each other. So what are we saying? Okay, so we are saying, well, log of QH is I1, log of QF is I1, and that's what causes the real exchange rate to be I1. But if log of QH and log of QF, they are co-integrated with each other, then there is a possibility that their stochastic trends, their unit roots, cancel out and make the real exchange rate to be stationary. Okay? So here we are saying, we are assuming that does not happen. Okay? Their stochastic trends do not perfectly cancel each other out. Okay? Again, that is a testable assumption. We test that, and we find that is not the case in the paper. Okay? Just to rule out the possibility, and if they are co-integrated, that's the, yeah, I'm not going to talk about it. So the third assumption is that these two variables are not co-integrated with each other. Okay. So basically, we test the model by testing the null hypothesis of stochastic cointegration and the deterministic cointegration restriction. Recall what is this deterministic cointegration restriction? Well, this restriction basically is saying that if there is a time trend in the real exchange rate and these relative prices, that should also get cancelled out by the same cointegrating vector, because there is no time trend in this equation. So that means if the underlying variables have a time trend, then the same cointegrating vector which eliminates the stochastic trend also eliminates the deterministic trend. Don't worry too much about this. Okay, so I'm going to skip the econometric methodology for now. Let's look at the data set. Let me tell you a little bit about the data. So the key thing is, how do we measure the relative price of non-traded to traded goods? Okay. So we use Q, remember? So this Q is the relative price, and one measure we have is this. So we think of the CPI as a measure of non-tradables because it includes things like transportation cost, advertising, all the non-tradable service elements, they are included in the CPI prices. But prices at the wholesale level do not include these non-tradable service components. So if we look at the ratio of CPI to WPI, that should provide us with a proxy for the relative price of non-traded to traded goods. Okay? Of course, it's not a perfect measure, it's only a proxy. But the advantage of this measure is that it is available for a longer time span. Okay? You could get some proxy which is more precise. So we also look at a second measure, and okay, so here CPI gives a much larger weight to non-tradable goods than does the WPI, and so that suggests that they should be reasonable proxies for tradable and non-tradables, and then these are available for a relatively longer time span, so from 1929 to 1988. Now the second data set uses total consumption deflator. Okay, so we look at consumption data. consumption data is divided into three components: services, durables, and non-durables. So here, we think of the service component of consumption as our measure of the non-tradable, and the durable plus non-durable component of consumption as tradable. Okay? So you look at different components of consumption and you classify them as being tradable or not tradable. And so here, this consumption data is available in current prices and constant prices. So based on that, you can derive price indices for tradable and non-tradable goods. Okay? So this, we expect that this data is more precise in measuring the relative price. Okay? The disaggregated consumption data should be more precise. But the downside is it's available for a shorter time span. Okay? So that's always the case, right? In empirical work, you always face these trade-offs. You may have a weak proxy like CPI to WPI, but then it's available over a long time span, right? Easy to construct and measure. Other one is more precise, but then available for a shorter time span because the governments didn't collect detailed data in the earlier years. So these things happen all the time. So let's look at the results now. So first, we are going to test the assumptions that we made. Okay? So what are the assumptions that we made? Well, we assume that relative prices and real exchange rates, they all have a unit root. Okay? So that assumption, we don't report the tests here because it's quite standard that you cannot reject the null of the unit root in most macro variables. So that's also what we find. Then we assumed that PPP holds for traded goods in the long run. Okay, that's an important assumption. PPP holds for traded goods in the long run. Okay. So if this is the case, then the real exchange rate based on traded goods prices should be stationary. Okay? And there's a typo here. This should be table 2. So table 2, please correct this. Table 2 reports the results of whether PPP holds for traded goods in the long run. So I'm going to skip table 1 for now and go to table 2. Okay, so here we are testing whether PPP holds for traded goods. Well, if it holds for traded goods, then the real exchange rate based on tradables, that should be a stationary variable. Okay? So we are doing two kinds of tests. The G tests, I'm not going to explain this in detail. The null hypothesis is different from the ADF type of test. Here the null hypothesis is that the variable is stationary. Okay? Null hypothesis is that there is no unit root. No unit root. For the ADF test, the null hypothesis is there is a unit root. Okay? But for the G tests, the null hypothesis is that there is no unit root. So the G tests, and you can see these are the p-values, okay? Generally, we are unable to reject the null hypothesis of no unit root. So that is telling us that PPP holds for traded goods in the long run. Okay? So it's consistent with PPP holding for traded goods in the long run. if you do the ADF test, you should be able to reject the null hypothesis of a unit root. That we cannot always do, and only in 2 out of these 6 cases. That may be due to the low power of unit root tests, which we have already seen. Like, our data span is not 200 years; it's much less than that. Okay, so basically we find evidence mixed. It's not very strong evidence because we can't reject this for every case. But overall, there is evidence that PPP may work better for tradable goods rather than for the overall price level. Then another assumption we made, remember, this identification assumption we made was that the 2 relative prices, they are not co-integrated with each other, right? So if they are co-integrated and they're canceling each other's unit root, then the real exchange rate will not have a unit root either. So we want to test, right? So we want to test whether this assumption holds in the data, and that's what table 1 does. So it tests the null hypothesis of no co-integration between the relative prices. So we look at the Dickey-Fuller. These are augmented Dickey-Fuller tests at different lags. And this is the I test. I'm not going to talk about this. But all of them, the null hypothesis is that there is no co-integration between relative prices, and you can see we are generally unable to reject this null hypothesis. Okay? So again, the data is consistent with the assumption that we are making. So if these 2 assumptions are met, then our model tells us that the real exchange rate should be unit root variable, and it should be co-integrated with these relative prices. Okay? So that's what we test now. So in table 3, we discuss the estimation of equation 6, that's for the real exchange rate, and we include wartime dummy for the Second World War because that's part of our sample. So there could be a structural break, so we want to control for that. Okay, now okay, so these are the results for the full sample, and this is up to the floating rate period, so excluding the Bretton Woods, post-Bretton Woods period. Okay. Oh no, sorry, it should be table 3. So this table is estimating equation 6. So recall, what is equation 6? That's the main equation that we derived. The real exchange rate is a linear combination, a weighted average of the home country's relative price and the foreign country's relative price of non-traded to traded goods. Alpha H is the share of non-tradables in the home country, and this is in the foreign country. So these coefficients we expect should be between 0 and 1, right? That they are a share. So that's what table 3 presents. Okay, now I want to say a few words about the procedure that we use to test for co-integration. This CCR procedure Okay, again, I'm not going to describe this in detail because of it can get a little bit technical. So the main thing that you need to be aware of okay, so why we use this procedure? First, the CCR procedure has co-integration as the null hypothesis. Okay? So most of the other tests for co-integration, like the ADF test, the Johansson test, they have no co-integration as their null hypothesis. But the CCR procedure has co-integration as the null hypothesis. Okay? Now, our economic model implies co-integration. Okay? So we want to have co-integration as the null hypothesis. So that's one reason we choose CCR. Second, if we look at the underlying econometrics of the procedure compared with Johansson, for example, so CCR is asymptotically efficient, but there are other asymptotically efficient estimators as well. For example, Johansson method is often used, but Johansson assumes a Gaussian structure. So it assumes the error terms must be normally distributed. Okay? But the CCR does not require this strong assumption of normality. Second, the small sample properties of CCR are better than Johansson. That's what empirical evidence shows. So Monte Carlo simulations show that CCR actually works better with small samples, which is what we have. With most macro data, samples tend to be smaller. Okay? So there's some other benefits as well, but let's not worry too much. Okay, so these are the results. So the first two, these two columns are the coefficients of the relative price in the home country and in the foreign country. So we expect this to be positive, this to be negative, and they should be between 0 and 1. They should be significant. So you have the standard errors in brackets, so they are significant. Here, these are tests of the null hypothesis of co-integration. Okay? So if the p-values are small, that means we are rejecting the null hypothesis of co-integration. Okay? So here, for example, you can see for the full sample, this is significant at 5%. Significant at 5%. So for the full sample, we reject the null hypothesis of co-integration. For UK and Italy, if we look at the sample up to the Bretton Woods, so we don't include the free-floating period, which was more volatile, you can see all the p-values are bigger than 5%, so we cannot reject co-integration here at the 5% level. Okay? So for the full sample, we can reject co-integration, but for the free-floating period, we cannot reject. And you find something similar for all the countries. Here, you see you can reject. Here you can reject co-integration, you can reject, but for the free-float period, you cannot reject. Okay? So, what do we find? For the full sample, at least one of the test statistics rejects the model. So out of the 3 test statistics we have, at least one rejects the model. But for the free-float sample, none of the test statistics is significant. So what this is saying is that there is evidence in favor of the model for the pre-float sample period, but not for the full sample period. Okay? When we use this measure for the relative price of non-trade goods. Okay? Is it clear? So this figure is hard to see. There's too many things going on. But the black line is the real exchange rate, and then the dotted line is the fitted value based on CCR, and we also draw an upper bound and lower bound based on two standard errors. So what you can see is that for most of the sample, except here in the floating period, the real exchange rate is often outside the two standard error band. So that tells us the model doesn't work so well in the floating period. But before the floating period, most of the time it is within the two standard error band. Okay, so I'm gonna skip the results for the other data set based on consumption. But let me just show you one picture, okay, which is the last picture. Again, so this picture is for log of the US-Japan real exchange rate. So this black line is the US-Japan bilateral real exchange rate, and you can see that this exchange rate is very volatile. So this is the post-Bretton Woods period, and it has been very hard to explain these large movements, like why the real exchange rate here falls, right, from 0.9 to 0.4. That's like a 50% change in the real exchange rate. This is in logs. Then you can see it appreciates back another 50%, and then again it depreciates. So these are huge shifts in the real exchange rate in the Bretton Woods period, and these are very difficult to explain for most macro models. But here we are able to show that the relative price of non-tradables seems to explain most of these big movements in the US-Japanese real exchange rate. Okay? So that tells us, now this doesn't happen for every country, okay? But at least for this country and for a few others, we are able to explain these big movements in the real exchange rate. So what this is saying is that, well, for some reason, there seem to be large and persistent changes in the relative price of non-traded to traded goods. And that is driving these large persistent changes in the real exchange rate. So then the question arises, well, what could be driving, what could be causing the relative price of non-traded to traded goods to move around so much? Okay, and thereby causing the real exchange rate to move around so much, thereby causing PPP to fail. Okay, so what is driving these relative price movements? And that's what we will look at after the break. So let's take a break now.
他上